How do you tell from a graph, a table, or an equation if something's quadratic? So from an equation, it's going to have a squared, and that squared is the highest degree. So the equation could look like y equals ax squared plus bx plus c, or there's another form of quadratics we commonly see. It looks like this. Both of these forms are quadratic in nature, and what's really noticeable is the squared. So when you see that squared, that's an indication that this is quadratic. For a graph, all quadratics look like parabolas. And so I don't actually need the table. We're going to build a table in the next step. But our graph is going to look something like this. Swoop! There's a parabola. So if it makes that shape, it is a quadratic. All right, now let's look at the table. We're going to make a table for y equals x squared, and I took the liberty of picking some x values already. So this first one, we would be plugging in -3 for x, so -3 squared is 9, -2 squared is +4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 4, 9. So some things I'm noticing from this table is I have a repeating pattern. It starts high, goes low, and then goes high again. That's because I have what is called the vertex in this table. This is the table that corresponds to this graph that we just made on the previous slide. For linear equations, I know what we do is we see if the rate of change or ratio of change is constant. Let's look at the rate of change for quadratics. So first of all, I see that all of my x values are just increasing by 1. My y values, though, are not following such an easy pattern. Going from 9 to 4 is a decrease of 5. 4 to 1 is a decrease of 3. This is a decrease of 1. This is an increase of 1, an increase of 3, and an increase of 5. So it looks on the surface that there's not really any kind of pattern there. At least the numbers aren't the same. But there is a pattern. Look at those numbers, 1, 3, 5. If I were to make another row and plug in 4 for x, 4 squared is 16, I can guess what this number is because I see that these are increasing odd numbers. I'm guessing the next number is 7, and sure enough, the distance from 9 to 16 is 7. The next one should be 9, putting this at a 25, and sure enough, if we plug in 5 for x, the y value would be 25, and so that's a step increase of 9. So this can be hard to tell, especially if you're looking at a table that starts like at this point and is scaled by some factor. We're using the most basic y equals x squared, but what if we had y equals -2/3 x squared plus 7x, or it's harder to see the pattern. So here's something else we can do. We can look at the change of the change. So here I see going from -5 to a -3, that's an increase of +2. From -3 to -1, increase of 2. -1 to 1, increase of 2. I think you probably see the pattern. So the change of the change is constant. So how can you tell from a table if something's quadratic? The change of the change is constant. Thank you.